we will try to devise a formula to find the sum of all the terms of an AP. Let us assume that we have an AP, for example 3, then we have 5, 7, 9, 11, 13, 15, 17, 19, 21. Suppose this much is the AP. Now if we have to add all these terms of the AP, what we can do is first write this same AP in the inverted way just below this one. Let's see. So 21 is the last, we write it as here, this 21, then 19, then comes your 17, 15, 13, 11, 9, 7, 5 and 3. Now you will notice something strange. Let's add all these which are one below the other. 21 plus 3, it gives you a 24. Again, 19 plus 5 gives you a 24. This 17 plus 7 gives you a 24. And you will notice that everywhere the sum is 24. Here, you can check everywhere. 19 plus 5, 24. 17 plus 7, 24. Everywhere the sum is 24. Now this is what the AN. And let's write the number of terms it has. This is first, second, third. So first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth and 10th. So 10th term. That means N's value here is 10. Now, when we have got this 24, how many times that means we have got 24? 10 times. Okay. 10 times 24. And what is this 10 times 24 actually? When you are going to add all this, we are going to get 2 times the sum of this AP. So what we write? If we denote the sum of an AP as Sn, then here we have 2 times Sn. 2 times the sum of the terms is 10 multiplied by 24 in this particular example. But now what is this 10? 10 is the number of elements. So we can write it as N. And what is 24? If you observe carefully, this here 3 is A and 21 is AN, the last term. So same way, this is A2 and AN minus 1. But everywhere the sum is the same. So in place of 24, we write A plus AN, which is the last term. So 2 times the Sn is N into A plus AN. So we can write Sn is equal to N by 2, taking the 2 here, into A plus AN. Again, if you don't know what is the last term, when we write the formula for this, so what will that become then? Then you will get Sn is equal to N upon 2 into A plus expression for AN, which is A plus N minus 1D. So that will be on simplification becoming N upon 2 into 2A. Okay, this A plus A will become 2A. 2A plus N minus 1D. So, one formula when the last term is given is this. Sn is equal to N by 2 into A plus An. In place of An, you can also write L. The last term is also denoted by N. If you don't know the value of L, the last term, you know only N, A and D, then you will use this formula. Then there is one more thing. Suppose the sum of the n terms are given and you have to find an, that is the last term. Then how can we find the last term? If you observe carefully, adding all the terms gives you Sn. And from that, if you want to find an, this is an, then an will be sum of all the terms minus sum of n minus 1 terms. If these all terms, their sum is subtracted from all the terms Sn, then you will get an. So another formula which we can use is an, that is last term, is equal to Sn minus Sn minus 1. This is another formula which you should remember. Let us understand this formula by an example. Here, a sum of 700 is used to give 7 prizes, such that each prize is rupees 20 less than the preceding. Find the value of each prize. So after you read, what do you understand? What you have to find? The value of each prize. And there are 7 prizes. That means we have to actually find all terms of the AP. And a sum of rupees 700. That means this is the Sn. Number of prizes 7. That means this is the value of n. And each is rupees 20 less than the preceding. That means this is the value of D. So you know D, you know n, and you know Sn. You are supposed to find the value of each prize. So let's first write the things that are given. Sn is 700, n is 7, and D is minus 20. Remember minus 20 because rupees 20 less. Let's put the values now. So Sn is equal to n by 2 multiplied by 2a into plus n minus 1 into D. Let's put the values. Sn 700 is equal to n is 7 upon 2 into 2, a we do not know, plus n is 7, n minus 1 will be 6. So 6 into D, which is minus 20. Taking 7 by 2 here, you get a 700 into 2 upon 7 is equal to 2a minus 120. In the next step, taking 120 here, and before that let's solve. 7 ones are and 7 hundreds are. So 100 into 2, 200. So here you get 200, then minus 120 here gives you plus 120 is equal to 2a. That gives you 320 is equal to 2a. That is 320 upon 2 is equal to a, and it gives a is equal to 160. So your first term is 160, but your answer is all the 7 prizes. So actually the AP. So the AP or the 7 prizes are rupees 160, rupees 140, rupees 120, rupees 100, rupees 80, rupees 60, and rupees 40. 1, 2, 3, 4, 5, 6, and 7. So all the 7 cash prizes are these. Let us see another example. 200 logs are arranged as follows. 20 in bottom row, followed by 19, 18, and so on the above rows. In how many rows all logs will be placed and how many in the top row? Now, let's look at the numbers first, what they are saying. 200 logs are arranged. So total logs are 200. That means this is the sum of all the logs. As follows, 20 in the bottom, 19, then 18, then that means this is your AP given with the first term as 20 followed by 19, 18. So from this we can also calculate the value of D. So we know Sn, we know D, and we know A. Then we need to find how many rows. How many rows? That means we need to find n, the number of terms. And how many in the top row? That means the last term an. So let us start working. First by writing the things that are given. So your AP is 20, 19, 18 and so on. Your Sn, sum of n terms, is 200. Then from this, A, that is the first term, is 20, and the difference, A2 minus A1, is minus 1. So D is minus 1. Now, let us use the formula for Sn. So, Sn is equal to n by 2 into 2a plus n minus 1 into t. Let's put the values. Sn 200. So 200 is equal to n upon 2 into 2 multiplied by a, which is 20, plus n minus 1 multiplied by d, which is minus 1. Let's solve further. 2 we take here. So we get a 400 is equal to n multiplied by 22s are 40. Minus 1 into n gives you a minus n. Minus 1 into minus 1 gives you a plus 1. So that's going to give you 400 is equal to, now 40 plus 1, that will give you 41, and when you multiply by opening the bracket you get 41n. So this will be 41n, and n into minus n will give you a minus n square. So here we get a quadratic equation in n. Let's bring these two terms on this side. So we get the quadratic equation in standard form is n square minus 41n plus 400 is equal to 0. Now to get the factors of 400, whose sum is minus 41, and it's going to be 25 into 16. So let's solve further. So this will be written as n square minus 16n minus 25n plus 400 equal to 0. That gives you n into n minus 16 minus 25 into n minus 16 equal to 0. That is n minus 16 into n minus 25 equal to 0. So you get n equal to 16 or n equal to 25. Two values of n. Now which will be the correct one? So let's suppose that we take n as 25. So if n is taken as 25, then our top row, how many it will have? So an, that is A25 will found out. So A25 will be A plus 24D. Try to find that out. So that will be A, which is 20 plus 24 into minus 1, which when you solve, you will get a minus 4. Now, you cannot have in the 25th row minus 4 logs. That is not possible. That means this value cannot be there. Now let's work on this. So A16, that's going to be A plus 15D. That will give you 20 plus 15 into minus 1. And when you solve it, you get a 5. So A16 is equal to 5. So this is your answer. That is, the topmost row will have 5 logs. And how many rows will be there? 16 rows will be there. So this is how you solve sums using the formula Sn.